Hi, I'd like to introduce ASL-Live. We're a senior design team from the University of Central Florida, and we're working on using machine learning and computer vision to translate American Sign Language. Our goal is to help bridge communication gaps and make the world a more inclusive place for ASL users. We're excited about setting a new standard in assistive technology, creating a tool that makes everyday interactions smoother and more meaningful for those who rely on ASL.
We've created a web application that captures American Sign Language through a user's camera and translates it into text, offering an accessible tool for seamless ASL communication and interaction. Due to the lack of abundant ASL data available today, a core challenge throughout this project has been collecting a diverse, high-quality dataset of ASL signs, gestures, and expressions. To overcome this, we've implemented data collection methods directly into our project, allowing us to capture the full range of ASL variations, enabling our dataset to represent the diversity of the language. By implementing this, we are building one of the most comprehensive ASL datasets available. Our broader goal is to establish a dynamic online ecosystem that not only serves as a translation tool, but also fosters ongoing data collection and model refinement. This evolving platform will rely on user contributions to adapt and improve, continuously enhancing translation accuracy. Our project is built on 3 pillars: high accuracy, data collection, and diversity in the data.
Now let's take a look at how ASL-Live works. Our system flows seamlessly from video capture to translation. First, video clips from the front end are sent directly to our model hosted on AWS, where the data is processed to identify and interpret ASL gestures. Once the signs are recognized, the translated words are passed to a language model to form coherent sentences. The final polished text is then sent back to the front end, providing users with an accurate real-time translation of their ASL input. Additionally, users can record their own ASL clips and submit them to our database. These user-contributed clips are stored securely in a database, allowing us to grow our training dataset over time, which enhances the model's accuracy and adaptability.
Here's how the project works. ASL-Live takes in video input through a webcam, where MediaPipe detects key landmarks on the hand, face, and body. These landmarks capture the intricate hand and body movements of ASL, allowing us to map each gesture accurately. Once these landmarks are plotted, we pass them through a k-nearest neighbors model, which classifies each movement based on previously learned signs. This classifier uses the spatial relationships of the key points to recognize individual ASL signs quickly and accurately. From here, we enhance the translation by utilizing our developed language post-processing architecture. LPP takes these individual words and phrases, connecting them into coherent, grammatically correct sentences in English. This step is crucial because it bridges the structure of ASL with fluent English, creating a smooth, natural translation for the user.
Let's talk more about how language post-processing works. Translating ASL sentences is no easy task. Translating ASL to English is referred to as text glossing, and we need to be able to connect the words to make a cohesive English sentence. To enhance our translation accuracy and to solve this problem, we came up with our language post-processing architecture, or LPP. Using LPP, we integrate OpenAI's GPT-4o mini model, which helps fill in the grammatical gaps and provides context to the translations. This integration ensures that our translations are not only accurate, but also contextually relevant.
To make ASL-Live even more effective, we adapted Google's Shua Gesture Toolkit, which was originally designed for Japanese Sign Language. One of our main tasks was retraining Shua for English translation, requiring us to adjust its data and models to recognize ASL-specific gestures and accurately map them to English words. By training Shua on an extensive American Sign Language dataset, we enhanced the ability to detect and interpret gestures unique to ASL.
Okay, so now that you know a little more about our model, let's talk about how it's accessed by the client. We integrated Flask with our machine learning model to handle video data processing efficiently, as its lightweight structure allows seamless routing of video data from our front end to our model with minimal delay. This integration enables us to transmit video data smoothly, making Flask a suitable choice for managing the communication between our model and our client interface. For hosting, we chose AWS due to its scalability, reliability, and secure infrastructure, which supports web application development with tools like Elastic Compute Cloud or EC2. EC2 lets us select instance types that suit our workload, balancing cost and performance. Additionally, AWS offers low latency and high availability features like elastic load balancing and auto scaling, ensuring that our API can handle traffic fluctuations. AWS's security tools such as Identity Access Management and SSL further enhance our API security by managing access and encrypting data, creating a very robust environment for hosting our Flash application. This emphasizes our goal of implementing responsible AI that ensures privacy of user data and information.
Our project leverages the Google Firebase suite for efficient and secure data storage. We use Firestore as our primary database to manage user information, while Firebase Storage handles the vast collection of video clips that make up our growing ASL dataset. Firebase simplifies uploading, managing, and retrieving user data, making data handling both efficient and accessible. This scalable infrastructure supports our goal of continuously refining and expanding our ASL translation model in a secure, user-friendly environment.
At ASL-Live, we've meticulously designed our platform to ensure it is fully responsive, providing a seamless experience across all devices, whether you're on a desktop, tablet, or mobile. This simplicity extends to our interface, where users can immediately engage with our Try It Out feature. Here, you can record a dynamic ASL sentence, and within moments, see the translation directly on your screen. For those who choose to create an account, there's an added layer of interaction. Account holders can contribute their own video clips to our database, directly influencing and enhancing the robustness of our ASL model. Every submission helps refine our algorithms, increasing the accuracy and reliability of translations for everyone. What's more, ASL-Live is completely free to use and is open source. By participating, you're not just learning ASL, you're also contributing to a larger mission of making digital spaces more inclusive. Remember, whether you're contributing data or just exploring ASL, your involvement is shaping the future of accessible communication.
The ASL-Live team believes that building something impactful means involving everyone who cares about making communication more inclusive. From the very start, we wanted our project to be open to all, so that anyone, whether or not they know ASL, can contribute in meaningful ways. Through our platform, users can submit videos of different words, which we then review and incorporate into our training data. This community-driven approach is what truly empowers our model's growth and accuracy. With the incredible support we've received, we've been able to host events and connect with people from all walks of life, each of whom has helped us move closer to our vision of an accessible ASL translator. Your feedback has shaped this project, inspiring us to improve and push our model even further. And it's because of this outpouring of interest and enthusiasm that we're expanding our goals. We want to keep gathering data, refine the model with community input, and roll out features that reflect what you care about the most. Every person who's joined us so far has left a mark on ASL-Live. And now, as we continue to grow, we invite you to stay involved and share your ideas. Now let's hear from some of the amazing individuals who've contributed to our data.
Alright, so what do you guys think about ASL-Live so far?
I think it's pretty fun, and I think it will be really useful for someone who needs help.
I think it's really innovative in the sense of, instead of compared to like a YouTube video or just your basic translation app into like words, it allows people to actually see and understand what's happening in real time.
I really like the project. I think the implications are great. I think it's definitely something the world needs.
Yeah, it seems like a really interesting project. I've never really messed with ASL before, so coming into this and like helping out is a really good introduction for the whole American Sign Language in general.
Has this inspired you in any way or shape or form?
It's inspired me to learn ASL more. I think it's a really interesting language that a lot of people use to communicate. Also just the AI kind of inspires me to look further into it.
Has, in a way that I could, like maybe there's something I could do that's similar to try to help people in the same way, like try to program teaching tools like that.
Yeah, so the projects I've worked on in the past have not been as fleshed out as this before. So seeing y'all's front end and how everything works together and integrates, it's been really cool. And I'm hoping, honestly, someday I could make something similar.
Thank you for watching. Let's bridge the gap, not make it wider.
Learn more at ASL-Live.com. Goodbye.